Same thing, except for multiple inequalities at the same time. But so there is a few levels of difficulties that are added, but not much. So same way as before, every inequality. So we'll have multiple inequalities on the same pane, each with their own solution panes. Okay? You must work each inequality separately so you make sure you don't mix them up. So shading systems. So here it is. This is where reverse shading really comes in. So shading systems. And I use the computer software to do this. Okay? It makes it difficult to determine the solution region for all inequalities. And then here's a different color. I'm going to use orange maybe. It is easier to determine the overall solution region if you use reverse shading. And we shade out the false regions. Right? Below is a visual of the difference. So would you be able to tell me in this graph which one is the solution region, which one is the darkest region? You can sort of tell, right? But this is a computer software that did this. This is probably the darkest region right here. This like little triangle here. They're not always triangles, just so you know. And reverse shading, we shade all the false regions. So this is my solution region. And let's go over here to this other and say this is technically my solution region here as well, this one right here. But you have to agree that this is easier to see. Much easier, right? So if you don't agree with me, that's fine, but I'll stick to it. Next, you need to worry about points of intersections. Okay? And we've talked about them a little bit. It's when lines meet. So highlight this part. The points where the boundary lines meet the solution region of the system. That's what POIs or corner points mean. Okay? So this one right here, if this is my solution region, then these three here would be considered corner points, POIs, right? So there's one there, and one there. There's three. And obviously we're using reverse shading, just making a note of that at this point. Where would be my solution region on this one? Right here. It's not contained in this case. It actually expands indefinitely. It's not contained. And so what's my corner point here, or point of intersection? There's just one POI. Okay. I will make a note next to this one. Note solution region. That's my way of shortening solution. Okay. Solution region not contained here. Sometimes it's contained, sometimes it's closed, sometimes it's not. Okay. Okay, so let's try one right away. So you know what, I'm just going to make sure, because when you go over your notes, you might not catch it. So I will go to the very top of this page and just say use reverse shading. I think this stands out, right? Use reverse shading. All right, 30. Let's do an example. And I use this notation on purpose, okay? You're okay with the notes? Yeah, you got it. Graph the following system of inequalities and identify the solution region on the graph. include the POIs, the corner points, points of intersections. Okay, it is a good idea to graph all lines on a calculator before graphing it on paper. I'm going to highlight that one. Once you have systems, I would encourage you to graph it on your calculator. What is it supposed to look like before you actually commit to putting it down on paper? So I used the textbook version of how they would present inequalities to you. It looks scary, but it is not. The inequality, the first one is right there. And the second one is right there. What's up with that weird format? It's just introducing the variables. We have variables x and y. This is the inequality. And we're told that x and y are both part of the real number. So meaning decimals, negatives, anything counts. Okay, that's all that is saying. So if I throw that at you, don't panic. It's fine. You're going to be all right. So let's call this one inequality 1. And let's call this one inequality 2. And I will work with inequality 1. So this is where you have to be organized and use your space wisely. Okay. Inequality 1, we're going to go 4x is greater than 6y plus 12. This is from a textbook. Is this how I want it to look when I'm trying to find my intercepts? No. I want the x and the y's on this side, right? So let's just change that around. I'm going to bring this over. So be 4x minus 6y is greater than 12. And you should immediately proceed, because graphing is part of this, proceed to finding the intercepts, and it shouldn't take you too long after a while. Divide both sides by 4. X is equal to 3. So it's 3, 0. Then it's negative 6y is equal to 12. Not always, but quite often you get some round numbers at least. Clean it up like this so it doesn't get too messy around your paper. What's the next step we normally want to do when graphing? You want to rewrite this, right? I do it under. So I'm going to go 4x minus 6y. There's no need to rush, right, from there to here. Just copy this down and then bring the 4x over to the other side. So it's negative 6y. 4x comes over plus 12. Divide both sides by negative 6. Let's see if you catch this. You have to flip the inequality, right? Yes. I did give you a heads up. Let's see if you catch this. Yeah. So you have to flip. So for now, because you're still noobs, hey, I'm old, but not that old. Okay. I can even throw in the OG, right? This is the OG right here. Okay. So flip because you're dividing by negative, right? Let's get back to work here. Dashed. Where's the true region? True region? It's less than, right? So it's below. It's less than, so it's below. Okay? Where are we going to shade if we do reverse shading? We're going to shade above. I really strongly encourage you to do this. So you know when it's graphing time, you've told yourself already shading above, right? Okay, keep going here. Let's do inequality number 2. 3y is less than or equal to negative 2x plus 9. This is not how I want it, so I'm going to bring the 2x over. It comes adding. The 3y is less than or equal to 9. Let's find the intercepts. 2x is equal to 9, divide by 2, x is equal to 4.5. These are there for you to graph the lines on the grid. That's the main reason, and to catch if you made a mistake. So 3y is less than or equal to 9. Divide both sides by 3. So I don't know. I shouldn't do the inequality in here, right? We're dealing with the boundary line. So it's just equal 3. So 0, 3. Clean it up. Rewrite. So I'm going to take that one, and I'm just going to show that the 2x comes over, subtracting, divide both sides by 3. No need to flip anything, right? Because there's no negative being divided. So you tell yourself this is a solid line because of the equal underneath the inequality. The true region, they're both less than, correct? Both of my inequalities have this, it's pointing the same way, so you should have the true being the same direction. If you go opposites, it doesn't make sense. You're contradicting, right? So true region is below for both of these, so but we're shading reverse, right? So we're doing this is probably the most important part when graphing, because you want to shade the appropriate region to get this right. So now we are ready to graph, but let's enter this into our calculator. So y1 and y2, let's go ahead and do that. Oh yeah, and you notice that I didn't reduce the fraction there. That is okay. You're not going to lose any marks for that. And so I always use brackets when entering my fractions, okay? And just don't forget the x variable. And I hit graph. It looks like I can do a zoom 6 here, a standard zoom. What kind of window am I looking at for zoom 6? It's a 10 by 10 each way. So in this case, you're fine. Your corner point is not going to be outside of the grid if you use a 10 by 10 by 10 at every direction. Okay? You see that? This is a standard zoom. We remember how to graph on calculators, I hope. Okay. All right, let's go and graph this now. This is a y, and this is the x-axis, and we're just going to label every fifth box in every direction. Then you're telling me what this scale is. How did I come up with my scale? The x-intercepts help me, but my window on my calculator helped me as well. So it doesn't matter exactly what scale you use as long as it's consistent. So let's see here. For the first one, it's 3, 0, 0, negative 2. Okay, before you graph this one, right? You have the intercepts. You go look over here. This is dashed. Right? So you're supposed to have a dashed line. Does it make sense for this line to go up? Positive slope, right? It does make sense to go up. Okay. Label it right away. To have this further up, I just want to see all the points. Next line is 4.5, 0. It's right here, and 0, 3 is right there. That is a solid line. Negative 2/3. x plus 3. This is not an inequality yet. Right now it's just a system of linear equations. But we want to do the other part. So for the first line, I'm shading above, correct? For this line right here that I've labeled, I'm shading above. So you go to with your ruler against that boundary line and start shading. So all of that is false, right? False. That's all out of, we can't use that anymore. The second line is also telling me to shade above. So I go to that second boundary line and just shade that. Leaving me with the solution region right here. I'm just going to say, right, true was below this line and true was also below that line, and that's why this ends up being my solution region. How do you find the POIs? Just go graph them and find intersection between these two. I already graphed it, so you go second trace 5. Because they're two linear equations, you can hit enter 3 times. You don't even have to look. There's only one point where they meet. So this is gonna be 3.75, 0.5. And I just go second, trace, intersect. Okay, so we've graphed it, lots of work, so you need to be practicing this to be able to be proficient and fast enough so this doesn't hold you back too much. Now, this is the last part, and I'm going to give you some class time to work on the rest. I want you to imagine for a minute that we didn't graph this thing just yet, okay? I just basically gave you, listen to this part, I gave you these two inequalities right here that we highlighted, and I just asked you randomly, is 4, 5 a solution to this system? Let's do it by observation. Is 4, 5, you think it's going to be a solution? 4, 5 is right there. It's not a solution. We know that already, but imagine we haven't done this, okay? So what you need to do is what? Sub in into all inequalities and see if true. That's just a little note there. I'm going to highlight that part because some students forget the all part. They just do it one and then it's like, oh yeah, that one works, so it is, right? It has to work for all of them. So I'm going to use the original here, and I'm going to substitute 4, 5 into it. So it's 4 times 4 greater than or equal, no, so it's greater than 6 times 5 plus 12. That's 16, and this would be 30 plus 12, that's 42. This is false, right? Continue. 3y is less than or equal to negative 2x plus 9. Plug it in. You have to watch out because the y is here, right? So what would go in there? It's 3 times 5, so don't mix it up. And it's negative 2x plus 9. So that'd be 15, less than or equal to negative 2 times 4 is negative 8, plus 9 is positive 1. And you can also tell that this is false. Therefore, not a solution. This is one thing. Right now, I did more work than was needed. You're listening to this, you want to save work, then listen carefully to this part. As soon as this is false, you're done. Okay, I'm just showing you the process. Okay, note, as soon as 1 is false, stop, okay? And then just state not a solution. So if I give you 4 or 5 inequalities and you have to plug them, as soon as the first one fails, stop doing the check on the rest because it needs to be true for all of them. Okay. Now it's time for you to try this. So I have a bunch there prepared for you, and yes, some of them are tricky. Listen carefully. I have only done one example. Okay. Will you have vertical lines sometimes? Yes. Will you have horizontals? Yes. I didn't check. There's one trick to graphing an X line. I wonder if I'm going to do that right now. Go to 31, and then it's you time. Okay. Trick to graph X equals to number, okay, vertical. You need to type in, watch this, you need to type in, I got this off of YouTube, okay? You have to put in 9 nines, and then you have to go X minus whatever the number is. And then it works out. So example, if you want to graph the X is equal to -5 line, okay, you would have to enter Y1, Y2, it doesn't matter. You'd have to enter 9 nines, so this is maybe worthy of adding it to your study sheet. What's X minus -5? It's really X plus 5, right? It's really X plus 5. So let's try that. It's actually pretty cool. I did not know this could be done all these years. So 9 nines. I'm pretty sure you can probably get away with fewer than 9 nines, but I'm not going to try it. And then X plus 5. Close the bracket. And then hit graph. See, graph that line there, the vertical. It will come in handy if you have vertical lines, and you have to find the POI, right, the corner point right there. Same, second trace 5, okay? So there you go. I will say this, I'll give you a heads up. Page 32, maybe leave that for last. So do 31 and 33 for now. (32) optional for now. That one is tricky, but if you like a challenge, you go for it.